Hello everyone. Today we will be discussing on compressibility and bulk modulus. Let's start with the definition of compressibility. It is defined as the reciprocal of bulk modulus. Compressibility is denoted as beta and bulk modulus is denoted as K. So from the definition we can say beta equal to 1 by K. Let us understand this in simple way. Let us assume certain fluid that may be liquid or gas. To that fluid, a force is applied. That force compresses the fluid, which means there is decrease in volume of fluid. Theoretically, it is considered that liquid is incompressible in nature as there is negligible change in volume, which is not visible to our eyes. But in case of gas, the compression or change in volume is clearly visible, so gas is considered as compressible in nature. And yes, when force is removed from the fluid regains its original volume, and so we can say the fluid is elastic in nature. So here we define compressibility of fluid means how much fluid compressed after application of force. And compressibility is measured as the reciprocal of bulk modulus. Let us understand what is bulk modulus. For this, let us consider or assume a piston cylinder arrangement. Within this, we assume some fluid is there. To this piston, initially, some external force will be there, and due to which we consider there is an initial pressure, that is P. And the piston is here. It means we consider this as the initial volume, that is V. Now we consider some more pressure is applied to this piston. So the pressure change. So the final pressure here we consider to be P plus dP. And after application of some more force or some more pressure, the piston moves from this point to this point. And we consider here this is the volume which is compressed, and that we consider to be dV. So here let us first consider the change in pressure. So initial pressure is P and final pressure is P plus dP. So change in pressure is final minus initial pressure. So final pressure is P plus dP minus initial pressure, that is P. So PP cancels each other and change in pressure becomes only dP. Similarly, we find out the change in volume. So initial volume is V and final volume. So after compression, the volume or final volume becomes, this is V minus dV. So this is final volume and this is initial volume. So what is the change in volume? That is final volume minus initial volume. So V minus dV minus V. So V cancels each other and it becomes minus dV. So here we are going to define bulk modulus. So before defining bulk modulus, let us discuss what is volumetric strain, or we first understand what is strain. So strain is nothing but it is change in dimension to original dimension. So basically here we discuss about volume as the dimension. So here change in dimension means change in volume. Here we discuss change in volume by original volume. So when we consider change in volume by original volume, that strain becomes volumetric strain and it becomes minus dV by V. So bulk modulus is, it is change in pressure to the volumetric strain. So change in pressure we already discussed, that is dP, and volumetric strain is minus dV by V. So next we find out the value of compressibility for liquid. So we know that liquids can be considered as incompressible. So how it will be incompressible, that we are going to prove here. So we know that density equal to m by v. So if we consider density equal to m by v and we rearrange this expression, so it becomes m equal to rho v. Now differentiate both the sides. So it becomes dm equal to v d rho plus rho dv. So dm means change in mass. So here we discuss about the compression. It means we discuss about the change in volume and change in pressure. But mass is constant. It means initial mass is equal to final mass. If initial mass is equal to final mass, so the change in mass is equal to 0. So 0 is equal to v d rho plus rho dv. So if we rearrange this expression, so it becomes d rho by rho equal to minus dv by v. So we know that bulk modulus, that is K equal to change in pressure dP by volumetric strain. So in place of volumetric strain, that is minus dV by V, we can substitute d rho by rho. So here it is d rho by rho. So if we rearrange this, we get K equal to rho into dP by d rho. So this is the bulk modulus for liquid. So here we are going to find out the compressibility for liquid. So compressibility is what? That is beta equal to 1 by K. If it is 1 by K, so beta equal to 1 by rho d rho by dP. For liquid, as we consider it to be incompressible, so it is d rho, that is change in density, is equal to 0. If change in density is equal to 0, so we substitute this value here and we get compressibility for liquid is equal to 0. Next, we discuss isothermal compressibility of a gas. For this, we use the ideal gas equation PV equal to mRT. So from the name, we can understand that the temperature is constant here because it is an isothermal process. And R is a constant. M, that is initial mass, is equal to final mass, that is before compression and after compression the mass remain constant. So the whole terms here we assume to be constant here. So PV equal to constant. Let's differentiate both the sides. If we differentiate both the sides, we get the expression PV P dV plus V dP is equal to 0. So rearrange this expression, that is V dP equal to minus P dV. And again rearrange this expression. So dP by minus dV by V equal to P. See, this is the ratio of change in pressure to the volumetric strain. So it means it is K, that is bulk modulus. So we can say bulk modulus is equal to P for isothermal compressibility of a gas. So compressibility is what? That is equal to 1 by K. So we can say compressibility of a gas for isothermal process is equal to 1 by P. Next, we discuss about adiabatic compressibility of gas. Adiabatic process is governed by an equation, that is PV to the power gamma equal to constant. Gamma is ratio of specific heat. So gamma equal to Cp by Cv. Cp is specific heat at constant pressure and Cv is specific heat at constant volume. Now let's come to the equation PV to the power gamma equal to constant. So we differentiate this equation. So after differentiation, we get an expression, that is P gamma into V to the power gamma minus 1 dV plus V to the power gamma dP equal to 0. Now if rearrange this equation, we get gamma P V to the power gamma minus 1 dV equal to minus V to the power gamma dP. Now in this V to the power gamma minus 1 can be written as V to the power gamma by V after rearranging this expression. So V to the power gamma is common in both the sides. So if we cancel each other, we get the expression gamma P equal to dP by minus dV by V. So see, here dP is change in pressure, and dV by V is volumetric strain. Minus dV by V is volumetric strain. So here we consider this dP by minus dV by V as bulk modulus. So we can say gamma P equal to K. So we can say here the bulk modulus for adiabatic process of gas is equal to gamma P. So if we consider the compressibility of adiabatic process of gas, it is equal to 1 by K adiabatic. So it is equal to 1 by gamma P. This is all about compressibility and bulk modulus. Thank you.